are we doing? All right. So, thank you everybody for joining. Thank you everybody for joining. What we're going to be doing is we're going to be learning how to read the abacus. This is a 3-digit puzzle. We're going to be identifying the hundreds, the tens, and the ones. That's what we're going to be doing. And I'm going to flip to a page. So the first thing we're going to do is we're going to understand how to read the abacus. After we learn how to read the abacus, we will go into understanding how to use it. So using it means by we're doing arithmetic. Arithmetic is adding, subtracting, multiplying, and dividing. Hello, good morning, good morning, good morning. So we have our number. We have hundreds. So there's 100 here. This is 5 plus 1 is equal to 6. So this is what 6 is. This is 600, 600. And then we have 10. So that's 1. All the lower beads touching this horizontal bar are being counted. So then we have 3. 1, 1, 1. The 3 all has a value of 1. Because these are a value of 1, they're considered 3. And then because they're touching this horizontal bar, they're being counted. So we have 613. That's what that is. Because we have our ones, our tens, and our hundreds. The top bead is touching, so this is the value of 5. This is why this is 6. Notice that there's no top bead touching here, so this is a value of 1. And then this one here is a value of 3. 1, 1, 1. There's 3 ones. So, good morning, everybody. Good morning. Thank you so much for joining. Thank you so much for joining. How are we doing? Hold on. There we go. Come on. There we go. Good morning, everybody. So that's what 613 looks like. We have our next number. So our next number is, let's see, our next number is, we have our hundreds over here. We have our tens and our ones. This is our hundreds. There's no tens. This is 0 because none of the beads is touching the horizontal bar. So that's 0. And then this is 3. 1, 1, 1. The bottom beads all have a value of 1. So when we're looking, we have 700, 0, 3. Ooh, that's what we have. Oh, that's right. And then, I wonder. Oh, sorry. Now I got it. Disconnect. Oh, that didn't work out. I gotta figure that one out. You're only using, oh, maybe that's what it is. Okay. So, hello everybody. This one is 700, 03. So that's what that is. 700, 03. And then we have our next number. I wonder how to do that. So, we have our next number. We have our hundreds, we have our tens, and we have our ones. What number do we think this is? So when we're looking, I wonder. Nope, that didn't work. Oh. I have to figure that out. So this is 277. Hello, thank you so much, Reese, for the tiny tiny. Thank you so much for the heart puff. Thank you so much. Hello, Robert. How's it going? So we have 277, and then we have our next number. We have our hundreds, our tens, and our ones. Thank you so much for checking in. For those of you that are interested, there is an orange heart me right above my head. You can click on that and become part of my community. It also helps the TikTok to know that you are a real person and you become like leveling up and stuff. And so what we're trying to do is we're trying to figure this out. Galaxy. Okay. So, no, that's the settings. This one's right here. All right, got it. Okay, got it. So this is 320. I got mine. You got yours. That's fantastic. That's fantastic. So you can follow along with me. That's awesome. So we have 312. I'm sorry, 320. And then we have our next number. What is our next number? So I have my hundreds, my tens, and my ones. notice that they kind of look the same, but the only difference is there's the top bead is as the top bead is touching the horizontal bar. Thank you, Reese, for the heart puff. Thank you so much. Oh, thank you so much. I appreciate that. So, oh, have a good day, Reese. Thank you so much. Have a good day. I'll see you. I hope to see you in my next live. Oh, wait, hold on. It is this one.
Oh, and in case I don't see you, good afternoon, good evening, and good night.
See you later, Reese. Thank you so much. Okay. So notice that they kind of look the same. There's all the same bottom beats, right? There's 3 here, 3 here, 3 here. The difference between them is that the top beat is touching. Because the top beat is touching, then that means becomes 5. Exactly, Robert. So we have 3, 1, 2, 3, and then 5. 5 plus 3 is equal to 8. 5 plus 3 is equal to 8. So notice that when the top beat is touching the horizontal bar, they are considered counted. So yes, it is 388, and then we have our next number. We have our hundreds, our tens, and our ones. So what number do we think? Remember when the top beat is touching the remember when the top beat is touching the horizontal bar, it is considered counted. There's 4 here, 1 1 1 1. There's 4 ones, 4 ones, and then the top beat is a value of 5. Thank you. Hello, Jacobed. Thank you. Oh, thank you, Gloria. Thank you. Right. So it's 993. That's what that is. Thank you. Yes, exactly. It is 993. I don't know. I'm going to try milliseconds. Now let's try. Okay. So, this one. Okay. Thank you so much. So we have 993. Okay. We have our next number. Well, notice that when I do this, none of the beads are touching. So what number do we think that is? This is easy. Because if none of the beads are touching here, the answer would be
Bueller. 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 Bueller.
Thank you, Haley. Yes, thank you, Haley. Thank you, Robert. Thank you, Squirrel. Yes, it is 0. So we have our next number. Thank you, everybody. Good morning, good morning, good morning.
Good morning, apartment. Good morning, doorway. Good morning, wall. Morning, ceiling. Good morning, floor. Ready to start the day.
Good morning, everybody. So we have our next number. We have our hundreds, we have our tens, and we have our ones. What number do we think that is? Thank you. Thank you. Yes, it is 582. Well done. Thank you, Squirrel. Thank you, Haley. Yes. So if you notice the top beat is a value of 5, that's what this is. And we have 3 bottom beats. This becomes 8. This is 5 because none of the bottom beats are touching. So this is 582, right? Simple to use, easy to understand. Thank you so much. Yes. Well done. Well done, everybody. What are the first 2 rows or the 2 columns? There are columns. And which book am I in? I'm in the 3-digit one. That's what I am right now. So, thank you, Haley, for the question. Thank you, Robert, for the question. Oh, maybe I should pin it. I'll pin it. Hold on. I always keep forgetting to pin it. There we go. That's what we're in this book right now. And so, if you notice, this is the ones place, right? This is the ones place. So because this is the ones place, anything afterwards is the decimals. So we have our ones, and then our decimal sits right here. This is our tenths, and this is our hundreds. Hello. Good morning, AI TikTok God. Good morning.
Step 2, greet the day, smile, and say, Good morning, city. Good morning, city.
And so, did that make sense? And when we're looking at something. Is this one? It's not that one. Where is it? It's my little piece of paper. So, good morning, AI TikTok God. Thank you so much. Thank you so much. So I'm going to go back to here. I'm going to do, if you notice, if you notice, we have our ones and then our thousands. This is our place value. This is our label. We have our ones and our thousands. It's for readability, just like we have the comma. The comma is for readability. So we have 3,456. That's what that would look like. And then we could take it one step further. We could do 73,456.25. Oh, hello. Good morning. Thank you, Stephanie, for checking in. Good morning.
Good morning, apartment. Good morning, doorway. Morning wall, morning ceiling. Good morning, floor. Ready to start the day.
Good morning, Stephanie. So, thank you. Thank you. I do appreciate it when you check in. I do appreciate it. Thank you so much. So, for this number here, if I have this one, this is a whole row of fives. Notice that there's the dot, this is the decimals right here. So this would be
55 burgers, 55 fries, 55 tacos, 55 pies, 55 cokes, 55 wings, 55 shakes, 55 pancakes, 55 pasta, 55 peppers, and 155 taters.
So this would be 55,555.55. So that's what that would look like. When we're looking, it's a whole row of fives. We could do a whole row of 7, and we could do a whole row of 9, or 8, and then we could do a whole row of 9s. 9s would be this.
99 problems, but a ain't one. If you having girl problems, I feel bad for you, son. I got 99 problems, but a ain't one. Hit me.
So this is 99,999.99. Thank you, AI TikTok God, for the reminder. Please, if for those of you that are interested and you guys like the content, go ahead and tap out the screen. Tapping helps me get to the. So all you got to do is just tap, because every time you tap, and you could do a 2-finger tap, right? And that will help bring up the thing. Abacus, yeah, I ate the bun. Yeah. So that's, and then if you notice, there's a little scale, and then notice that if I try to make it all the way to the top, it will give me confetti. So that's what that would be. That's what tapping it out means. So for those of you that are new to TikTok, that's what tapping out means. Tapping means just to tap and liking. Thank you so much. I do appreciate it, because it helps the algorithm. It helps the algorithm know that we're a happening live, and also it pushes out to the FYP. So what I'm trying to do is I'm trying to introduce Abacus to the Matrix.
Welcome to the real world.
So, yes, thank you. And yeah, 99 problems, and the Abacus ain't one of them. Yeah, totally. So I hope that made sense, and then we're going to continue on. Thank you so much for joining. Thank you so much for joining. So we have 993. That's what that is. We did 0. We did that one. Oh, right. We did that one. Okay, we're up to this one right here. So we have our next number. We have our hundreds. We have our tens, and we have our ones. What number do we think that is? Thank you, everybody, for joining. Thank you, everybody, for joining. Good morning. Good morning.
Good morning, apartment. Good morning, doorway. Morning wall, morning ceiling. Good morning, floor. Ready to start the day.
So we have 120. 1 and a 2 and a 0. So thank you, Gloria. Yes, thank you. It is 120. Thank you, Stephanie. And then we're going to take our next number, and it goes up to here. So, Robert, did that make sense what book I'm in? Oh, I should. Okay. So we have our next number. Oh, I pinned it. That's right. So we have our next number. We have hundreds, we have our tens, and we have our ones. What number do we have? So notice we have one. There's 4 ones here. So this would be 4. This is 1, and this is 1. So it's 114. Thank you, Gloria. Yes, thank you, Stephanie. And then we have 114. Thank you, Ebony. Thank you, Ebony. Jackie's. Thank you, Jackie's. And then we have our next number. This is easy, because when we're looking, it's only the hundreds. So we have our hundreds over here. we have our tens, and we have our ones. Thank you, Stephanie. It is because we have the zeros. There's zeros over here. Just because there's zeros over here, we want to remember our place value, right? We want to make sure that we keep the zeros as our placeholder, because it's just like in our paycheck, this is 300. It would suck if this was actually just 3 for our paycheck, but actually it's 300, so that's kind of nice, right? Oh, I bought the 5, it was so basic. Yes, thank you, yes. And so the you would be doing the maze, and that's what this is. So it would be an example of the maze. No, that's a 2-digit one. And then the 3-digit one is this one. And don't forget, Robert, that there is this mask maze to help you cover the answers. And then what I would do is I would fold it in half, and then there's this. Don't forget, there's your placeholder, and it's up to you if you want to put it on a cardboard, and it's supposed to line up like that. And it's supposed to line up like that. So notice there's the indicator right here. So this is the ones, the tens, the hundreds, the thousands, and the 10,000s. It's this one right here. For those of you that are interested, I'm going through the adult book. And then you could choose any one of these to be your ones place. Because I choose this one to be my ones, I'm over here. I put mine on a thin ruler. Oh, yeah, that's a good idea. And then this one is actually, if you choose this one to be your ones place, then you move it over and you do that. So you have your ones, your tenths, because your decimal sits right here, your hundreds, your thousands, your 10,000s, and your and your 100,000s. So the idea for this was that it should be able to line up. Yeah. And then if you wanted, Robert, if you wanted, you can download this, and then you can get a thicker, you can put it on a thicker piece of paper. So what I did is I put it on a file folder. This is a file folder. Or you could put it on construction paper. I put it on construction paper. Let me show you if I can find it. Excuse me. Oh, I can't find it. Where did it go? Now I want to find it. Yeah. You could put on construction paper. Anything thicker than the paper that we have. Oh, I could do that. Yep. All right. So that's what it is. I use cardstock. Oh yeah, cardstock is good too. And then yeah, so the mazes themselves. So if you want more mazes, they're in this book. There is a 2-digit book and a 3-digit book and a 4-digit book. So those are the mazes. Yeah, if you want more mazes. But I felt like in the Abacus one for the adult ones, I didn't think that was needed. That's why you give a little sample of the mazes. I didn't put too many in because I was focusing more on the actual numbers themselves, like adding and subtracting. So just to give you another run through, here the idea is to figure out what the number is, right? So what number is this? I don't know. Okay, let's do this one over here. So let's do this one over here. What number do you think that is right here? So we have our number, we have our thousands, our hundreds, our tens, and our ones? No, ones. What number do you think that is? Thank you. Thank you, Robert. It is 9,517. And we're going to add that to what number is this? Sorry, 800. You're right. 800. Thank you. Thank you for the correction. 800. 8,517. And then we're going to add, what number is this? It is, that's okay. What number do we have here? 81. It is not 81. It is 30. It is 1, because the top 8 is not touching. So when we're looking, we want to add 31 here. We want to add 31 here. So when we add 31, it is 3, 1, 1, 1, plus the 1. So we have 3, that's what we did, 30, and then 1. So what is our final answer? Our final answer is thank you, Robert. Yes, it is 800. I'm sorry, 8,548. That's what that is. 8,548. Okay? So this is what we call simple adding. It's simple adding because there's no need for formulas. And then we go into subtraction. Subtraction is if you know how to add, you know how to subtract. It just means that if I have the 8 over here, I want to take away 1, all I got to do is take away 1. That's what we're doing, right? What if 2 bead is down? If 2 beads are down like this, then that would be 5. So it depends on what it is. What if 2 bead is down? What does that mean? I don't know what 2 bead is down mean. Because we have 4 digits. We have 8,548. So which 2 beads are you talking about? This one has 4 beads and they're down. Because there are 4 beads that are down, this is not counted. That's why this is only 5. If I have 1, this is 5 plus 1 is 6. Oh, what if the 2 bead is down? What does that mean? Oh, if you subtract. So if I have 9 here and I want to subtract, I take away 2. If I want to have 9 here and I want to subtract 3, I take away 3 beads. If I have 9 here and I want to subtract 4, you take away 4. That's what that means. If I have 9 and I want to take away 5, you just remove it. You just move it away. So you add, you go to the horizontal bar. You subtract, you go away from the horizontal bar. So yes, exactly. Thank you, Kyle. Yes, exactly. The top bead is a value of 5, and all of this is a value of 1. Yes, exactly. And anytime the beads are touching this horizontal bar, it is considered counted. So right now I'm only doing 1 column. So this is the ones place. I have 2. This is not 2. This is not 11, right? What this is 29 because every column is a place value. We have our ones, our tens, hundreds, thousands, and 10,000s. So when we're looking, we don't add the columns together. This is not a one-to-one. This is a representation. Every number is represented on the abacus. So what we're doing is we have 29. Cool. Could you show me multiplication on it? And can you factor on it to break codes? I can show you multiplication, but you need to understand how to read the abacus first. And when you say factor, what are we factoring? The only thing that the abacus does is it helps you visualize your numbers. I'm not sure why people are kind of confused with that. It only shows you numbers. It's only a number representation tool. That's all it does. If you can factor, you have to factor in your head and you use the abacus to help you represent the numbers. That's all that is. Can you do, yes, you could do multiplication and you could do division. You can also do subtraction and addition on the abacus. Can you use it to help, yes, you can use it to help multiply. All it is just bringing it together. Okay, so before we continue on, ooh. Try that. Okay, so we're going to continue on to doing some adding and subtracting. We could do multiplication if I can get to 10,000. We can do multiplication. But what we're going to do is we're going to do a review on this book, a little flip through of the basic math abacus for adults. So what we're doing is we're doing addition, subtraction, builds confidence, and promotes critical thinking. That's what we're going to do. So yeah, if you want to see multiplication, let's get up to 10,000 and I can do that. Because it'll be very easy. when we're doing the so Robert, just so you know, this is pixel art. The pixel art is supposed to be super easy, but the idea is to continue on to just just work with the numbers. So we have 7 on the abacus. We have 7 on the abacus. I want to take away 2. To take away the 2, I just remove it like that, right? And the idea is, I know you could do it in your head, but I want you to see the numbers. I want you to see the beads as they move. And so the idea is just to be able to make sure you see and you get used to the beads moving. That's why there's the pixel art. And then we go into adding of the 5, and then subtracting of the 5. I give you activities, right? And here, this is just to help you to fill in the extra number. So what we do, remember, when we add the 4, we have 4 on the abacus. We have 4 on the abacus, just like that, right? And what we're going to do is we're going to add another 4. Now, we don't do this because that would just be 44. What we're going to be doing is we're going to be adding it to the ones column. We need to add 4 to the ones column. In mainstream, what do? They count up. But in abacus, we don't need to count up because we know a concept. Do you remember the concept? The concept is how to make a 5. How to make a 5. How to make a 5 is 1 plus 4 is equal to 5. That's what this is. So when we're looking, right, what we're doing is we're understanding this concept. This is 4 plus 4. In mainstream, in public school, they're like, okay, you just got to count up 5, 5, 6, 7, 8. But in abacus, we're going to start doing the small steps of regrouping. So regrouping means what? I don't have any more beads to add the 5. I have no more beads to add the 4. So what do? I have to make a 5. I have to round this beads up at the bottom to round up to 5. To do that, I need to have an extra 1. The 1 has to come from somewhere. The 1 will come from the previous number. So you got to take away 1 from here. So I got to give away 1. So we add the 4, and now we've made a 5. So this is now 5. Do you see that? So we added the 5. Why? Because we are rearranging and we're doing a little bit of regrouping. That is why. And so this is the beginning parts of regrouping, which is what happens when we work with the tens. We do that with the tens as well, but we're taking it one step further and we're making it into a smaller chunk. So what we just did is we did a regrouping. We have 5 plus 3 is equal to 8. 5 plus 3 is equal to 8. So that is about how to make a 5. What we just did is we understood that we had to grab a 5, right? This rounds up to 5. We always look at the second number. So Robert, just so you remember, right? We always look at the second number. Don't look at the first number. The first number, you don't want to be able to make that a 5. You want to make the bottom number a 5. So in this example, like here, we say 2, right? We have 2 on the abacus. And we have 4. I'm sorry, we have the other way. We have 4 on the abacus, and we have 2. Now, you might be like, oh, if I want to make a 5, I'll make the 4 a 5 because it's closest to the thing. But the problem is where are you going to get the 1 from? You don't know your next number. So what we're doing is we're going in sequential order, right? We're going like a running total. You always go from top down. So then the next question is, oh, here's my 2. What do? Well, I want to add 3. Why? Because I need to round this up to 5. To do that, I have to take away 3 from the 4. So I take away 3 from the 4 and I add it to my 2 to make a 5. So now I've done is I've created a grouping and I made 6. So it's just like in drifting. You have to go right to go left. Thank you, Mel, for the follow.
If you're going hard enough left, you'll find yourself turning right.
Oh, right. That makes perfect sense. Turn right to go left.
All probably just use one of the many calculators that are in every piece of technology we own. You know, you're right. I think my dishwasher has a calculator. That's fantastic. And do you use a car to go to to go walking down the street? Do you use a car to walk from the front of your door to your car to drive into your car? You do need to walk right? That's what we're doing, is we're walking, we're exercising. Do you go to the gym to go exercise, or do you just sit around and do brain rotting? You know what I mean? So what we're doing is we're exercising our brains. You could use a calculator. I'm not judging. There's no judgment. I use a calculator. Everybody uses a calculator. But what we're trying to do is we're trying to exercise our brain. Like you go to the gym, like you walk, right? You're walking to places. When you walk, I don't know if you walk. I don't know if you touch grass. Oh, I shouldn't judge. I'm not judging if you don't touch grass. That's okay. But see, the thing is I usually exercise my brain with practical things. That's very interesting because multiplication is practical, adding and subtracting is practical. You're so good. That's so good. You're so good. But if you didn't know that arithmetic is practical, then it might be kind of stop your judging. So, but then if you don't want to learn, then you don't need to be here. You can leave. I'm just here to introduce what an abacus is. If you don't like it, you can leave. I'm not here to force you. Am I forcing you to stay? Oh my, thank you so much. I ate too much lasagna. Ate too much. I'm forcing lasagna to stay. Thank you for staying. Thank you for staying. Thank you for all the comments. Thank you for wasting your time if you don't choose to learn. Good morning, Lola. Good morning, Lola.
Step 2, greet the day, smile, and say, Good morning, city!
Robert. Oh, you didn't like that? You didn't think that was funny? I thought it was pretty funny. I thought it was funny. All right, so let's get back. So literally, I had an argument about this. But yeah, good morning. There's no judgment. You want to use a calculator, that's fine. There's no judgment. There's no judgment. I'm perfectly fine. All right. So what we're going to do. So Robert, just so you know, we're not going to round the top beat. You always got to look at the second one. You know what I mean? Always look at the second number, because in Abacus world, we want to know and we want to do a running total. That's why. In mainstream world, which is really fascinating, in mainstream world, the focus is always on the first number, but then you don't know what to do with the first number. So like this one right here, I have 7 on the abacus, right? If I have 7 on the abacus, what do? Am I going to add or am I going to subtract? Thank you, Lola. I'm here against my will. George. So yes, I have the best people. All right. So we have 7. Oh, I'm going to add. But you know what? Hello, Can of Cricket. Good morning. But guess what? What we're going to do is minus the 3. To minus the 3, what are we going to do? Well, we know that we have 7 on the abacus, right? This is what 7 looks like. So we have 5 and then 2 on the bottom. When we want 7, we want to take away 3. Remember, what we're going to do is we're going to break the 5. So we got to break the 5. Do you see that? When we break the 5, now this becomes part of the collective. To make it part of this to become the collective, we have to add the 2. So we break the 5 to add the 2. So our final answer is 4. You know what I mean? So when we're looking, we're understanding the concept. You want to make the 5 and you want to break the 5. I want to trace my 9-year-old daughter. Oh, yeah. Yeah, that'd be great. And so when we're looking, right, when you're looking, you might want to start, Mariella, you might want to start with the mazes. So 9, either a 3-digit maze or a 4-digit maze. Either a 3-digit maze or a 4-digit maze. And so because they're a little bit older, I would recommend either the hundreds, the tens, and the ones as the number to read, or as the thousands, the hundreds, the tens, and the ones. Thank you, Serbio. Yes, nothing. Nope, not a problem. Because you kind of came in. I've been on for a little bit, and so when we're looking, we're reading the abacus. We have 1, 2, 3, 4, and then 5. The top beat is a value of 5, and then we have 6, we have 7, 8, and then 9. Does that make sense, Serbio? So when we look at it, this is 9, right? You might be wondering, what's 10? 10 is 1 and a 0. We have, hello, Kyle. We have 10, 11, 12, 13, 14, and then 15. The toppy is a value of 5. No matter what, the toppy is always a value of 5. So when we have this number, and we do a whole row of 5s, oops, sorry. We do a whole row of 5s like this, we have 55,000.
55 burgers, 55 fries, 55 tacos, 55 pies, 55 cokes, 55 wings, 55 shakes, 55 pancakes, 55 pasta, 55 peppers, and 155 taters.
It doesn't matter. I would recommend, so I'm sorry, so this is 55,555.55. I would recommend using the label. This label right here tells me that this is the ones place. Notice I have another label over here. That woke me up. Good morning. Yes, good morning.
Good morning, apartment. Good morning, doorway. Morning wall, morning ceiling. Good morning, floor. Ready to start the day.
So does it matter? I would recommend using one of the labels for readability. So just like we have commas as a readability, we have our 3,456. That's what that is. Does that make sense? Hello, yes, man. Thank you so much, Ken of Cricket, for the tiny diny. So does that make sense, Rubio? We have the comma for readability, just like it's a little difficult to see. So that's why I would start at the ones place. I would start at any one. You could choose this one to be your ones place. So then you would choose it like that. And then what you could do is you could do here. We could do 0.00001. So it would be a really, really small number. Why do you put it under the ones place between the ones? Is that custom? Why do I put it under the ones? Because it's a label. That's all it is. The dot is a label, and you can't move it. The dot is just a label to tell you where you started. That's all it is. Is it custom? It is common. It's common. It is part of a lot of the other the modern abacus. So this is a 13-column abacus. A 13-column abacus is a little bit bigger than the 7-column abacus because size matters. And so when we have a bigger abacus, we would have our dots, right? You could choose any one of these dots to be your ones place. So you could choose this one and you'd only have 4 numbers, right? Ones, thousands. 1, 2, 3, 4, right? Or 1,000, 2,000, 3,000, 4,000. However, if you want to choose this one to be your ones place, then you would be ones, thousands, and then millions. Yes, Edie, size matters. The bigger the number, the bigger the abacus, right? So we have our next one. We could do this one to be your ones place. You have your ones, your thousands, your millions, and your billions. So using the dots is a label, not a decimal. That's the difference. Because what would you call these ones over here? You know what I mean? So if this is my ones here, what do you call this one? That's not a decimal, right? Because there's only one decimal. That's why it's a label. Use it as the label for what it is. So you can have your ones, and then this would be your thousands. So notice I have my ones, tens, thousandths, and then hundredths. See that? So now we're using it as readability. It's for readability. You can go any which way you want. You go left to right, right to left. It doesn't matter. You can even go here. So if I start here and I want to go all the way down to here, I don't want to have to count where I am, right? I know every grouping is my comma. So we have our ones, we have our thousands, we have our millions, we have our billions, and then we have our trillions. You know what I mean? So when we're looking, use it as a label and not the decimal. Don't be confused with that part. All right? Okay, so we got that, we got that, we got that. Oh, so we have that. I disagree. I would do trillions on the small abacus. You only need one bigger one for the... You could modify it, but as far as you can go would be millions. You can't do trillions. You would have to like kind of bring it together. So I rearranged this one, ones, thousands, and then millions. But you can't do trillions on the small abacus. I don't know how you do it. How would you do it? I could do trillions on the small abacus if you only need the bigger, ones for more. Incorrect. 10 trillion minus 9 trillion. Oh yeah, you could. You could, right? But then now you're just adding zeros that doesn't matter, right? But what if it's like 9,348,678,000? Then you're not doing very well, right? Because then you can't keep track of all those numbers. But yeah, right. You're absolutely right. No, that's absolutely right. Because that's the same thing about scaling, right? In Abacus world, you could scale it. Whereas in mainstream world, it's very difficult to scale. Why? Because it's just like this is a very, very simple concept. But like you could do 3 times 8. You're right. You could do 3 times 8. Or you could do 9 minus. You're absolutely right. You could 10, right? Minus 9. Minus 9 is minus the 10 plus the 1. Right? You could do that, not a problem. It's the same thing with this one, right? We have 5 and we have 3. You could do it with the dots. You could do it with the tally marks, like mainstream math. There we go. Mainstream math does the dots and the tallies, but in Abacus world, you could do 5 plus 3 is equal to 8, or you could do 50. Right? 50 plus 30 is equal to 80. This is 8 and a 0. Or you could do the dots. It's up to you, right? A floating point of the calculation. Yep, exactly. And so the abacus helps you represent, right? And all it is just about representation. If you choose this to be your millions, sure, you could be this as your trillions. Doesn't matter. But that's why the dot's there. The dot is for your label. Exactly. It's absolutely right. So if I want to do 800, we do 800 is 500, and then 300, 300. This is now 800. So, what are the 2 top beads? Oh, here, wheels. Oh, hey, wheels. Sidebar. But it's all abacus. Is it really a sidebar? All right. So here is the Chinese abacus. A Chinese abacus works very similar, but the concept is different. Actually, the concept in Chinese is that they the concept in funny thing about the Chinese one is that they use counting up. In the abacus world, in the new abacus world, we actually use concepts. So we could still count. There we go. Hold on. Let me. Oh, I've lost my bricks. Let me do that. All right. Here we go. Trying to clean up a little bit. All right. So the Chinese abacus. Thank you for the follow. So the Chinese abacus is very similar. We have 1, 2, 3, 4, 5, and then we have 5. So because we have 5 here, we're going to trade it into the 1 here. So we have 5, and we have 6, 7, 8, 9, 10. And then we're going to trade this in. Because we have 5 here, we're going to trade that into here. But then because we have 10 here, we're going to trade this into here. This is not meant for really counting. It's more for meant like tallying up some stuff. So that's why I really want to know where my bricks are. Oh, here it is. So the difference is in abacus world in the new abacus world, we use formulas. The formula is how to make a 10 and how to make a 5. In the old world, they did a lot of counting up, is what the mainstream math is doing. So when you're adding, right, you count up. You go, 4 plus 6. So what do? They add the 6 like this, right? So then you have to trade this in. This becomes 10, and then this becomes 10. But in abacus world, we actually know concepts. We know that 4 plus 6 is equal to 10. When we're looking at it, we have 6 on the abacus. I'm adding 4, right? So in the modern abacus, I have 6 on the abacus. I want to add 4. Notice to add the 4, there's not enough beads. But what I do is I need to make this one a 10. I need to add 6 to down here. So adding 6, so I have to take away, the 6 down here to make a 10. I have to take away the 6 to make a 10. That's how that works. Whereas in mainstream, not mainstream, in Chinese abacus, the numbers are already there. So even if we did, so here's a question. If we did 5, if we did 5 and we want to add 7, right? We want to add 7. To add 7, because I have 5 here, all I got to do is change this out, make this 5. This is 5, and then add 7. Adding 7 is 5 plus 2 is equal to 7. And so what's my answer? My answer is 12. 10 is here, so I'll move that over here. So that becomes 12. So it's more like adding up than doing, so it's a little redundant, but it works depending on how you do if you don't do the formula, right? So even if we do, so let me do that again. If I have 5 in the question, I want to add 7. Well, I see that this 5 is the same thing as this 5. So now I can add my 7. So adding 7 is 1 bead on top and 1 bead on bottom, and you bring it together. So this becomes 12. How do I know? This is 10. 5 plus 5 is 10. And then this is 2. 5 plus 5 is 10. Let me trade that into this. So it's a little bit more trading. Wait. Was that really confusing? Can you do it on the new abacus? Yeah. So on the Chinese abacus, on the Japanese abacus, we have 5 on the abacus, right? It's a little bit more complicated. So we have 5 on the abacus. I want to, sorry, can't see that. We have 5 on the abacus. I want to add 7. So this is where you really need to know your formula. You really need to know how to make a 10 and how to make a 5. Now what we're doing is we're Tetrising our way through. So what we do is if I want to add 7, right, make 7 into 10. How do I do that? I only have a 5. Guess what? I have to break the 5. I have to break the 5. Oops, sorry, hold on. Why? Why do I have to break the 5? To break the 5, why? Because I need a 3. This 3 I have to break. So I take away the 3 here, and I need to add it here. So I'm left with 2. So I break my 5, and I add the 2, because that's the 2 up here. And I've made my 10. So this one's a little bit more complicated because you have to Tetris. You really need to understand how to make a 5 and how to make a 10. What grade is this for? It's for the fun grade. It just depends on how old you are. It's for the fun grade. And so what we're doing is we're doing basic arithmetic. You can teach the kids as young as 5 this concept, because the idea is, why are we teaching the kids how to make a 5 and not use it? Right? Why do we teach how to make a 10 and not use it? In Abacus world, we actually utilize this concept. So, what's the advantage of the newer one? The advantage of the newer one is it's faster. There is no competition abacus for Chinese abacus. There is competition for the Japanese abacus because it's a lot faster. The world record person holder that was able to add 100 lines under 30 seconds because they were able to use the abacus method. The abacus method is faster, and it talks about critical thinking. So what we just did is we did critical thinking, right? It promotes critical thinking. We have 7 on the abacus. We have 5 on the abacus, and then we have to assess, what are we going to do? Well, I know I need to add 7, but to add the 7, I have to remember that I have to break my 5, right? Break my 5, take this 3, add it to my 7, so now I've made a 10. But then, don't forget, this needs to be added to the abacus, and that becomes 2. So the formula that we use is minus the 5 plus the 2. That's why. And, Robert, you're going to get into it when we talk about the 2-step equations. So this is a little bit more, this is a little bit on the advanced side. There is a whole methodology, there's a whole workflow in Abacus world to be able to do this, right? So, hello, Joseph. So when we're looking at it, pay attention to the workflow. Let's do this one. 7 plus 4. If I want to add the 7 to the abacus, no, I'm going to add the 7 to the abacus. Right? We want to add 7 to the abacus. So you add 7 to the abacus. I want to add the 4. Adding of the 4 is what we want to do. What can we do? Well, is there enough beads to add the 4? Yes or no? No, there's not enough beads to add the 4. Can you make a 5? No, because you're already using the 5. So you cannot make a 5. You cannot use this 5. You cannot add the 5. You cannot round it. Does that make sense? So then you have to use the 10. Now you have to make a 10. So if I want to add the 4, right, plus the 4 is plus the 10 minus the 6. So you plus the 10 and you take away the 6. Did that make sense, Robert? So when you're looking at it, there's a whole workflow. You go through each step. Can you make a 5? No. Can you make a 10? Yes. That's all it is. And it's the same thing with subtraction, right? If I have 17 on the abacus, I can ask, do I have enough beads to take away the 4? Can I take away the 4 here? No, I cannot take away the 4. What do? I go here. Can I take away the 5? Yes. So I have to minus the 5 plus the 1. Minus the 5 plus the 1. And my final answer is 13. Did that make sense? So when we're looking, we have to really know our formulas. We really need to know our fact families. The fact that the fact families are very crucial, and it'll become better. It'll become solidified. So then it becomes automatic, and it'll be in no time you'll be able to understand it. But you just got to kind of work through it. Because why? Because when you start going to 7 plus 7, that's when you start have to Tetris your way through. So here we have 7 on the abacus. I want to add the 7. To add the 7, I know it's plus the 10 minus the 3. So I plus the 10, but look, I cannot take away the 3. To take away the 3, what do? I have to minus the 5 plus the 2. Minus the 5 plus the 2. So my final answer is 14. Yeah. Obviously, I'm on page 51 now, right? So you go through the concepts, and as you get to here, it will be a lot easier to understand. Because you go through the motions, and that's why I try to provide as much exercises, and I try to provide exercises and how it pertains. And then here, some people got confused. Here is we're doing repeated addition. So we have 4 on the abacus. 4 times 1 is 4, right? We add 4. 4 times 2, add another 4. How do you add a 4? Well, when we add a 4, there's not enough room to add a 4 here. What do? We have to plus 4 is equal to plus the 5 minus 1. So you plus the 5 minus the 1. Do you see that? And then you write their answer here. And then you want to add another 4. So 3 times 4 is what? Add another 4. We can't add a 4 here. What do? We need to, yes, thank you, Robert. So now we want to add another 4 here. What do? Plus 4 is equal to plus 10 minus 6. Plus the 10 minus the 6. My answer is 12. So 3 times 4 is 12. And then we add another 4. How do we add a 4 here? Just like before. Plus 4 is equal to plus the 5 minus 1. Plus the 5 minus the 1. So my answer is 16. So write the number 16 here. And then we want to add another 4. Well, why? Because 5 times 4 is what? Add another 4. Plus 4 is equal to plus 10 minus 6. So you plus the 10 minus the 6. See how there is my answer? My answer is 20. So put 20 here. And then we add another 4. Why? Because it's 6 times 4. 6 times 4 is just 4. So my answer is 24. So this is what this means. This is what we call repeated addition. So there's no formula involved, so you don't need to write a formula. But here, I want to do 7 times 4. 7 times 4, I want to add another 4. Can I do it? No. This is where the critical thinking is involved. The critical thinking is, well, how do I add the 4? To add the 4 is right here. Plus the 4 is equal to plus the 5 minus 1. Plus the 5 minus the 1. So my final answer is 28. And then I want to add another 4. Well, guess what? I have no more room to add another 4. What do? I have to plus 4 is equal to plus the 10 minus 6. Plus the 10 minus the 6. And then we do it again, right? We want to add another 4. Because why? We have 4 times 9. You only need to go up to 9. Don't do anything higher than that, because anything higher than that is distributive property. And we just do distributive property on the abacus. We don't need to memorize anything. Oh, thank you, Cricket, for the tiny diny. I just saw that. Thank you, Lola, for the Go Popular. Ah, nuts. So add another 4 plus the 5 minus the 1. So my final answer is 36. Yep. So those are the exercises. And I like them. I like them. I hope they work well for you. All makes sense. Yeah, right? It's crazy. It's crazy. But this is such a simple tool. It's the funniest thing. All we're doing is we're looking at the number. The abacus only shows you what the number is. How do I get the book? Oh, this book is available in my TikTok shop. Let me pin it. There we go. Hello. So yeah, this is my book. This is my book. This book is Basic Math Abacus. Addition, subtraction, builds confidence and promotes critical thinking for adults. It can be for older kids too. I would say maybe like 10, 11, 12, because there's not a lot of exercises. Oh, that's right. So Robert, you also got the +5 book. So it's up to you for the +5 book, right? The +5 book is this one right here. And I make it slower. So the idea here is to understand the number lines. Just to understand the number lines, right? Can I get... Can you get a... I haven't made it into a PDF yet. If I do, it would be on my website. I can't sell PDFs on TikTok. But if you don't like, yeah. Oh, so yeah, yeah, it'd be on my website. I have like other activities if you wanted there. Okay, so the flip through of the +5. Now this is just to go a little bit slower, and there's more exercises. And again, it was meant for children that are 5, 6, 7, and so I didn't want the questions to be too complicated, but we still have to understand how to make a 5, right? To make a 5, we have like 3 cats here, and then we want to, 2. And I do have a fair amount of adults working through this workbook. So we have all the different versions of how to add the 4. So 4 plus 1, 2 plus 4, 3 plus 4, and then 4 plus 4. And then we do it again with the 3. So you'll see that it's a little bit of a slower pace. This one is a +3, then there's a +2, then there's a +1, and then I give you the activities. The activities, again, is the color by number, and then there's the mazes, right? The idea is that you need to answer the question, and again, it's a running total. Don't go up and down. You do the running total. So I have 8 on the abacus. I want to take away 6, so take away the 6, and then I want to add the 3. Add the 3 is what? Plus the 5 minus the 2. So that's how you get 5. So my final answer is 5, and then we do this, right? We follow this path. We go to 5, and then we go down here. It's easy. Yeah, it's perfect. Yeah, it was meant for all ages. And to be also interactive, I know a lot of the adults have gone through this as well, because it's and what I do is I really solidify the concept of how to make a 5. That's what this whole book is. It's all about how to make a 5. And then we talk about like color by number, and then the mazes, and then connect the boxes and tic-tac-toe. Yeah. And then there's answers in the back of the book. How does 4 plus 4 equal to 5? 4 plus 4 does not equal to 5. That is not what I said. What I said was you make a 5 to add the 4. There we go. Cool. I'd really like these books. Yeah, so these are all my books. I created all these books. This one is available also in my TikTok shop. That one is there. Yeah. So I pinned it for those of you that are interested. So just so you know, if you want the others, then the next step would be minus the 5 and then plus the 10 and then minus the 10. And then I'm still making my other book, which is the 2-step equation for the kids. So it'd be a 2-step equation. And then after that would be multiplication, and then we're going to do division. So after this book for adults, it would be multiplication. And that's the one I'm still trying to wrestle with on how I want to figure that out. Yeah. So all right. Whew, that's crazy. Okay. Yeah. And that's it. Yeah, the two-step equation's a little tricky, but it's only tricky because you're not solid in your formulas. Once you're solid in your formulas, it would be good. All right, cool. So we can continue on with this one. So Mike Jones. Who is Mike? Who Mike Jones? We're going back to here, understanding what 4 plus 4 is. So on the abacus, we add the 4, but what we do is we have to make a 5. Now, why? Well, instead of counting up, what we do is we use concepts. What? Yeah, use concepts. So we have 4 on the abacus. That's what 4 is. We want to add another 4. Now, instead of doing this, what you're doing here is you're just making it 4 tens. What? Yeah. So the abacus is a representation of the units. So every unit, every column is a unit. We have our tens. We have our ones and we're our tens. We don't want to add 4 here. Who? I don't know. It's Mike. Yeah. So what we want to do is we want to add 4 here. Adding 4 ones. You could count up. That's what mainstream math does. You could count up 5, 6, 7, 8. You could do that. But in Abacus World, what we do is we use a concept of how to make a 5. How to make a 5 means what? I want to round up to 5. 4 plus 1 is equal to 5. 4 plus 1 is equal to 5. Where does the 1 come from? The 1 has to come from the previous number. So we have to give away 1, right? Give away 1 minus the 1 to add and make a 5. Now I've regrouped and I rounded up to 5. That's why I add the 5. So my final answer is 8. So what do I have to do? I had to give away the 1. Thank you, Ashley. Good morning, Ashley. Good morning.
Good morning, apartment. Good morning, doorway. Good morning, wall. Good morning, ceiling. Good morning, floor. Ready to start the day.
Good morning. Thank you. So for 3, and we want to add the 4, again, when we add the 4, what are we going to do? We got to plus the 5. We got to round this to 5. To round this to 5, we got to get the 1. The 1 has to come from somewhere. The 1 comes from the previous number. So the 1 comes from the previous number, and you add it and you round it to 5. So that's what that is. So we added it to 5. We rounded it to 5. So our answer is 7. We have 5 plus 2 is equal to 7. I do like this one much better. So then we could do it again with the 2. So you have 2 on the abacus. I have 4. Again, see what we're doing is we're just solidifying the concept. The concept is minus the 1 plus the 5. And we could do it again with all the others. So we minus the, we want to make this a 5. To make this a 5, so can you move it to the far right, being the leftist? You could. You could. You could use this one if you want. You could use this one if you want, but it's still ones and tens. Does that make sense? So you could use this one. It's up to you. So we could do 2 over here. But then if there's more numbers, then you're kind of stuck, right? And you don't want to go backwards, because the way the place values are is how it's represented. I mean, if you really wanted to, you could go the other way. You could say that this is your ones, this is your tens, this is your hundreds, this is your thousands. You could do that. However, now you're going backwards, even if you're a leftist. You're making it way more difficult. Why confuse the kids? Why? Hello, beans! That's very judgy. That's very judgy. I don't go to your live and judge. I don't go to people's lives and just judge. So going back, the leftists, so you could, does that make sense too? It was to Sancha, right? So yes, you could use it here. But I would still go ones and tens, because that's how the numbers are represented. The numbers are represented. It's a question. The question is not, you're making this more difficult, is being judgy. That's being judgy. The point is to understand, yes. So does that make sense to Sancha? So you could do, I wouldn't, because it's not how it's represented, but you could do this. That's not a problem. It doesn't matter what you use. You could use this one here or this one here. It's actually when you physically see the numbers, yeah. See, you're very judgy. Who is learning this way? Apparently, you don't know those kids that do this, that do the flipping of the gang signs. Those kids that are flipping of the gang signs, they're actually doing Abacus. Thank you, Ashley. So, yeah, so you could, not a problem. But yeah, the one problem is that you can't do that. So that's why I would recommend to here, because then you have all this room to do your place values. Ones, tens, hundreds, thousands, and then 10,000s. Even if you're left-handed. But, even if you're left-handed, they say you should still do the calculations with your right hand. But I do see kids do both hands. So it's up to you. It's up to you. I don't know if there's a study whether to do the calculations with your right hand or your left hand. I don't know if there's a study for that, but there's no problem if you do your calculations with the left hand or you do calculations with your right hand. It's up to you. If you write with your left hand, then you could hold the pen, right? You can hold the pen. And you can hold the pen and then do your calculations. You could do that too. So, maybe just move, yeah. So, okay, so let's do a little review for those newcomers. So we have 1, 2, that's what 2 is, 3, 4, and then 5. The top is a value of 5. We have 6, 7, that's what 7 is. 5 plus 2 is 7. We have 8, 5 plus 3 is 8, and then 9. 5 plus 4 is 9. And then we have 10. 10 is a 1 and a 0. Hello, Mark. Welcome, Mark. Thank you so much for learning. Thank you so much. Good morning, Mark.
Good morning, apartment. Good morning, doorway. Morning wall, morning ceiling. Good morning, floor. Ready to start the day.
You're absolutely right. You could learn math for free. You don't need to be here. You can go learn it on your own and have your own pace. That's fine. I've learned a lot. I have our books. Yeah. Hello, Mark! I want the physical one, though. Interesting. The physical one does do a lot. Because I tried my best to, add in the add in the pictures. But having the physical one really does make a difference. So when I do an explanation like this, we want to, what are we doing here? We're doing minus the 5. So we have 5 on the abacus. We have 5 on the abacus. I want to take away 2. And then I try to give you the pictures, but the pictures don't do justice with the actual moving, because you want to move it like that. Do you see that? You want to move it. And it's just satisfying. And it's tactile. And it's different than on the phone. So there's the abacus on the phone. Yeah, using your hands in real copy will improve your skill. Yeah, just like handwriting and just printing out, just like doing cursive writing, or even just like writing on a piece of paper. That brain hand-eye coordination really helps, because it's different than pressing down. Pressing down doesn't tell you anything. It doesn't tell your brain that you're pressing the G key, the L, because you're just doing the same motion, which is pressing down. Whereas on the abacus and handwriting, you're actually moving your hand to the shape that you need, which is really interesting. It's really important to practice. Yes, exactly. And so that was the one thing, was to make sure you keep your brain active. Ha! You guys are awesome. You guys are awesome. Thank you guys. I appreciate you guys. Thank you. I need to have a little, that's what we want to do. Because we want to level up our brains.
Level up, 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 level up.
So, and that's what it is. Yeah. Yeah. All right. How are we doing? Good morning, everybody. Good morning.
Good morning, apartment. Good morning, doorway. Good morning, wall. Good morning, ceiling. Good morning, floor. Ready to start the day.
And then we're just continuing on, right? So when we add the 3, right? When we add the 3, it's the same concept. Because what do? We're going to take away 2 to make a 5. So we do 3 on the abacus. Let's do 3, right? We'll do 3 plus 3. Again, in mainstream math, you could count up. It is up to you. Or what you could do is you could use the concept that they already teach you. They teach you that 3 plus 2 is equal to 5. What page is that one? What page is this one? This one is page 17. I'm on page 17 in the plus 5 book. So when we're looking, we want to do the same. What I was trying to say is like the 5 cats in the tree. But I think what it is we have 3 cats in the tree. We got to add 2 more cats. That's what it is. I got to add 2 more cats. Where are we going to get the 2 cats from? The 2 cats has to come from the first number. So you got to take away 2 from the first number to add to here. Now I've made a 5. Add a 5, take away the 2. So now my final answer is 6. 5 plus 1 is 6. Yeah, that works out very well. So if we do, because what we want to do is want to have 5 cats here. The 3 goes to the 5 cats. You have 3. Let's do it again. So I have 4 on the abacus. I have 4 on the abacus. 1, 2, 3, 4, right? I have 3 cats. So I'm going to color in 3 cats. This means I need to get 2 cats. 2 cats has to come from somewhere. 2 cats will come from the 4. Yes, thank you, Demetrius. I noticed the cat's in the tree. Right? So you need to get 2 cats. Where are you going to get the 2 cats from? The 2 cats will come from the 4. So you have to take away the 2 here to add it to your 3. So now I've made a 5. Now I've made a 5 because I took away 2. Yeah. I just noticed cats in the tree. Yeah, the cats in the tree. I was trying to get the kids to understand how to do adding of the 5, because it's a little bit of a bigger concept and nobody really talks about how to round up to 5. And so that was the beginning parts of understanding. Now we have 7? Yes, now we have 7. Now we have 7. So we have 5 and then 2 is 7. Yeah. Because we made our yeah. So instead of adding up, you use the formula. Ooh, I like that. I'll be sure to add you so my kids can watch your stream. Okay, thank you, Demetrius. Yes. Thank you. Yeah, it's very visual. It's very visual. So we can do it again with the 4, right? And the 2. So what we're doing is we're looking at the 2. We're not looking at the 4. See here it says add the 2? The second number is what we need to focus on. This scratches my brain. It's very different. It's very different. My friend, it was so funny. My friend is a teacher of 20 some odd years. He teaches second grade. I told him this way of math, and he goes, "Why does it make it sound better?" And I'm like, "It's because we're getting stuff." Hello, Reaper. I'm gonna need my coffee. So working top down. Always go top down. So we have 4 on the abacus. I want to add 2. If I add the 2, what do? Yeah, it applies to a puzzle to basic math. Yes, exactly. Thank you, Ashley. Have a good day. Have a good day.
Oh, and in case I don't see you, good afternoon, good evening, and good night.
See you later, Ashley. Be well, be healthy, keep exercising. It applies a puzzle to basic math. Yes. And it can be applied to difficult math. Yes. Yes, exactly, Beans. Exactly. So we'll get to it. You know what? We'll get to it and I'll show you. Oh, I found a few ones. I found a few that's like really complicated, but it was exciting. So we'll take it over here, right? We do 4, right? And then we want to add 2. Adding the 2 was what? We need to get, what do? We need to get 3 from somewhere. 3 to make a 5, right? We got to get the 3 from somewhere. The 3 comes from the 4. So we take away 4 here. So we take away, we take away the 3 from the 4. So I take away from here and I add it to my 5. And I add it to my 5. So this becomes 6. So now we have 6. I made the bracelet. Yay! I'm so happy you got the bracelet. Right? Did that help? I was hoping that it'd help. Thank you, Robert. I made the bracelet that came with it. It was kind of nice, right? It was a little bonus that if you buy from me, you get a little bracelet. I was trying to add in like little, and then don't forget to get the column. I think you got the column isolator, right? The column isolator is a little printout that you can isolate the column if the numbers get too big. So we only work with 2 numbers at any given time. You either use the 1s or you carry the 10 or you borrow the 10. So you have the column isolator. Yeah, that's a printout. That's funny. So, there was that one question. So here is a crazy question I got. Let's see if I can find it now. I got to do this one. Is it this one? No. Oh, I don't know where I put it. No, I've lost it. I have to go find it. It was really good. It was really crazy. Oh, maybe it's over here. Hold on. Oh, here it is. Yes, yes. So here's some of the questions can get really crazy. This one, no. I'm excited for this one. Oh, no, there we go. So here's a number. I like it. It helps so I don't lose my blocks. Yeah. Okay, so this one, it was kind of interesting. 1596 plus 57. This gets a little bit, it's like a little puzzle, which is fantastic. So let's figure this out. So we have 1596. This is from one of my other books. The book that I'm working on right now is So this is another book. The book is adding sequentially 1 to 100 or subtracting. So this is this is another book, but this is more like practicing. And so what it is what you do is you do 100 plus 99 plus 98 plus 97. So then you keep a running total, and you try to get to like 550. So one of the numbers that we came across was 1,596, right? We know we want to add the 5. So what's adding the 5? Plus the 5 is equal to plus the 10 minus the 5. So we're here. We want to plus the 10 minus the 5, right? And then we're here. We're 7. Plus 7 is equal to plus the 10 minus the 3. So I plus the 10 minus the 3 plus the 10. How do you add the 10 here? This is where it's a multi-step. You can't add the 10 here. How do you add the 10? Adding the 10 is what? Adding the 10 is just like 1, right? Plus the 5 minus 4. So plus the 5 minus the 4. And then here, you want to minus the 3. Can you minus the 3? No. You cannot minus the 3. So what do? Minus the 3 is minus the 5 plus the 2. Minus the 5 plus the 2. So your final answer is 1,653. Yes. Thank you, Robert. Did you do that on the Abacus? Let's go, right? But see, that's what I'm saying. It's like a little puzzle. You know your stuff. You know how to do this. You will know how to do this. We can do another one. Yeah, that's what I'm saying. Like, it's so crazy. I don't know why people want to keep going like, let's do multiplications. Like, adding and subtracting is really fun. Here's another one. Okay, we do 3, 5, right? And then we want to add 41. What grade is this? Right now, I think we're in grade 3. I think this would be grade 3 because it's 4 digits. I think it would be grade 3. I'm not sure. So we have 3, right? 6, 5, 5. Add the 4, not a problem. Add the 4. Add the 1. Well, what is 1? We know plus the 1 is not enough. So we have to plus the 1 is equal to plus the 10 minus the 9. So we plus the 10 minus the 9. Whoa. Okay, there's a lot going on here, right? So we want to plus the 10 first. Plus the 10 cannot add the 1 here. So plus the 1 is equal to plus the 10 minus the 9. Plus the 10 minus the 9. And then we want to minus the 9 here. Minus the 9 is what? Minus the 9 is equal to minus the 10 plus the 1. Minus the 10 plus the 1. I didn't do that right. Oh no, that's wrong. Not minus the 5. Not minus the 9. It's supposed to be minus the 10. Minus the 5. 1 is equal to 5. No, that's right. Hold on. I did that wrong. 33, 6, 5, 5. Oh, I did that wrong. Oh, that's right. Oh, no, that's the wrong one. I wrote it wrong. Because this is 40. This is 1. That's all we're doing. No. That was a wrong one. I think I wrote that wrong. I mean, it should have been maybe 7. Nope. Maybe it's a 7. Yeah, I think it was supposed to be a 7 here. Sorry, wrong one. I'm still building it out. I think that's what it is. I think it's a 7. Okay. Never mind. That was easy. Poor Jake was probably hoping. Okay. Yeah, that was wrong. Here's another one. Let's try this one. 3916 plus 89. 3916 plus 8 plus 9 plus 8 plus 9 plus the 9 is equal to plus the 10 minus 1. So let's minus the 1 here, and we're going to plus the 10 here. Plus 10 is the same as 1, right? Because it's 1 and a 0, 1, 0. We want to plus the 1 here. So plus 1 is plus the 10 minus the 9. So you minus the 9 and you plus the 10. Can't do it. Got to do it again. Minus the 9 plus the 10. So my final answer is 4005. Yeah. Yeah. I was going to add this one. This is going to be like advanced. Yeah. Thank you, Miss Tanya, for the follow. Thank you, Red, for the follow. Thank you, everybody, for the follow. Okay, and we're gonna continue on. Yeah, it's very interesting. Like you're right. It's like a little puzzle because you know the concepts. You know the basic concepts. The basic concept is how to make a 5 and how to make a 10. If you know these concepts, then you can actually add and subtract at scale. And so notice I go top down. I don't go up and down. I'm not excuse me. Yep. Here we go. And then okay, we'll do the next one. I gotta move my stuff. Okay. Huh. I wonder. Where are we next on? We do 4, 5, 6, 5. So this is more advanced stuff because of the multi-steps. So we talked about how to make a 5 and how to make a 10, but then you're going to see how once you know those fundamental blocks, then it doesn't matter what you're doing. So we have 4, 6, 5, 6. So what we're doing is visualize our numbers. We know what it is, right? Thank you, Red, for the follow. And we want to add 97. Add the 9, add the 7, add the 9. So plus the 9 is equal to plus the 10 minus 1. So plus the 10 minus the 1. Cannot take away the 1, right? This is where you get critical thinking. And this is what they call mental math, I guess, right? Because the idea is I want to minus the 1. Minus the 1 is equal to minus the 5 plus the 4. Minus the 5 plus the 4. And then we have to 7. We want to add the 7. Plus the 7 is plus the 10 minus the 3. So I plus the 10 minus the 3. Plus the 10 minus the 3. Plus the 10. Can't plus the 10. What do? I know plus 1 is equal to plus the 5 minus 4. Plus the 5 minus the 4. And then over here, minus the 3. Minus the 3 is minus the 5 plus the 2. Minus the 5 plus the 2. And my final answer is 4,753. Gosh, it's so pretty. And it's kind of relaxing when you start doing things like that, you know what I mean? Because you're really focusing on the numbers and you're just clearing your brain just to do this. You're not thinking anything else. What you're doing is you're looking at the abacus and you're looking at your number and how do you get this solved, right? I mean, obviously you could use a calculator. It's up to you. But for the most part, I like it because it kind of provides that sort of meditation when we do it. And in saying out the numbers, I think saying out the formula really helps. Yeah. So question, do the numbers go by tens depending on the row? That's a very good question. Actually, it goes it goes by tens? It's by place values. So when we're looking, we have every number as a place value. So we have our ones, our tens, hundreds, thousands, and 10,000s. That's a very good question. So notice I have a dot right here. This dot tells me this is the ones place. So this is going to label, it's just a label. We have our ones, our tens, hundreds, thousands, 10,000s. And then over here would be our decimal. This would be our decimal, and this is our tenths, and then this is our hundreds. Yep. You could choose this one to be your ones place, right? Because if you notice there's two, this one is my thousands. Okay, this is the last bit, and then I'm going to head out. So this would be your ones, and then you move everything over like that. So you can actually use this to be your ones, and then you have a really, really small number. Yeah, right? And then you have your a really, really small number. We could talk about our decimal. Like this. So, oh, I can't see it. Hold on. There we go. So we could do 0.00001. You could do that. Yep, you could do that too. Yeah. It's very interesting. And you could choose these dots to be anything you want. You just like I believe it was Kyle, right? Kyle said that you could choose this to be your millions and then this one to be your trillions, and then you could say, okay, if I have 2 million and I want to add 9 million, 20 million, add 9 million, right? Then I have 29 million. So you could imagine the others if they're all like zeros and stuff. All right. What was the last number? It was. Good job, Robert. Good job, Robert. Well done. It was good, right? This is what I'm going to, this is the new, another book is going to be called The Advanced One. Not a problem. It was a very valid question. Thank you so much for the question. Thank you for the question. It took me a long, yes. Good. Good. But yeah, that was going to be, there's going to be 2 books. One is going to be the practice abacus, where you do sequential adding. So what it is you do, and then I was going to break it up into, different skill levels, beginner, intermediate, and advanced. Okay, I am almost done. Yep. So yeah, this one is addition from 1 to 100. And so what I wanted was you write the formula, and then you have the answer. So this would be like the beginners, and then the intermediates would have like remove some of the running totals, and then in the advanced, it'd only be just the running total. It would just only be the numbers. Yeah, it gets really crazy towards the end. That's a lot. Yeah. So that's one way. And then the second way is to go, so this is 1 to 100. This one would be 100 to 1. And then there's going to be a subtraction. So there's going to be a subtraction one, which is going to be, I think, a little bit more difficult. So this is the subtraction one, where it's subtract 1 to 100, and you start with 50-50. And then you go down. And then the other way, you go 50-50 minus 100. It seems good for financial calculations. Yeah, it was in the beginning. Abacus started off as a business tool. It started off with like trading and understanding how to trading back in the day of Mesopotamia, and so that's when it started. And then it has now evolved into this, which is now for the kids that go mental math. But it's interesting. The abacus is viewed as a toy, but it's actually a math tool. Hello, Stuart. Hello, Stuart. Good morning, Stuart. Good morning.
Step 2, greet the day, smile, and say, Good morning, city!
So, but I'm gonna head out, Stuart. I just came on just to say hi and good morning, and then I was gonna head out. We're gonna go to the gym. I gotta go get some exercise. I gotta go. Yeah, you too, Robert. Thank you, Robert.
Oh, and in case I don't see you, good afternoon, good evening, and good night.
Thank you, Robert. Have a good day. Have a good day, everybody. Just letting you know I got... Yay! I need the practice. Oh, yay. You got an abacus. That's fantastic, Stuart. I'm excited for you. I'm really excited for you. I hope it works well. We were just doing some advanced adding and subtracting. Advanced addition, actually. I'll go into subtraction in a little bit, but yes. Have a good day, everybody.
We are so glad you came. Bye-bye. 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 Bye-bye now. Bye. Bye-bye. Remember, please discard all candy wrappers and popcorn containers in the nearest trash receptacle. Thank you. Okay, bye-bye now. Bye-bye. Bye. Okay. Are they all gone? Is everybody gone? Huh? Good. Oh my gosh, my cheeks are killing me. I can't keep smiling like this anymore. I am exhausted. I think I need a break. A little break? Okay.
Thank you, everybody. Have a good day. Have a good night. Have a good morning if I don't see you.
Oh, and in case I don't see you, good afternoon, good evening, and good night.